Hey GED students, it's GED question of the day time, and I'm wrapping up a little stretch of divisibility problems. Let's take a look at this example. If a number is a multiple of 10, what am I saying? I'm saying if it's on the 10 times tables, it must be divisible by which of the following? If it's on the 10 times tables, which of these numbers would divide it perfectly with no remainder? So, well, I don't know. Let's experiment. Let's list out our 10 times tables at least for a while. So 10, I'm counting by 10s and I get 20, 30, 40, 50, and so on and so forth. I won't do all my 10 times tables because then I'd have to count by 10 forever, and I don't have that kind of time, y'all. So let's examine the first few here. Now, I'm wondering which of these numbers it'll be divisible by. We can check divisibility by doing a quick divisibility check. Hopefully you guys know these rules already. If you don't, I would go back and review my divisibility rules. But a number is divisible by 2 if it's even. In other words, if it ends in 0, 2, 4, 6, or 8. I'll take a look at all these numbers. 10, 20, 30, 40, 50. They are all even. And no matter how far I kept going, 50, 60, 70, all these numbers would end in a 0. Numbers that end in 0 are always even. Therefore, everything on the 10 times tables would be divisible by 2. Now let's check for 3's. The trick for 3's is what we call a sum of digits trick. You can find a factor of 3. In other words, you can see if a number is divisible by 3 by adding the individual digits of the number. And so that's what I'll do. I'm going to add the digits of 10. 1 plus 0 is 1. 1 is not on the 3 times tables. Think of the 3 times tables. 3, 6, 9. Of course, 10 is not either. So that number is not on the 3 times tables. In fact, many of these numbers are not on the 3 times tables. Therefore, there's no way I can conclude that something on the 10 times tables must be divisible by 3. I found an exception to that rule already. I'm going to rule that out. Now let's think about how to tell if a number is divisible by 5. A number is divisible by 5 if it ends in 5 or 0. That's another final digit divisibility trick. The whole 5 times tables ends in 5 or 0. We'll look at the 10 times tables. Every single number on the 10 times tables ends in 0. Therefore, every single number on the 10 times tables would be divisible by 5. So this must be true. Now think about your 7 times tables. Unfortunately, I do not have a trick that I find very useful anyway for the 7 times tables. And so I always recommend to my students that if you're going to memorize any times tables, make sure you memorize your 7s. So thinking about our 7 times tables, 7, 14, 21, obviously these numbers 10, 20 don't show up on it. These numbers are not divisible by 7. Same thing with 11. If I think about my 11 times tables, it's not like all these numbers on the 10 times tables are also on the 11 times tables. That's just silly. Okay. So clearly we've just found out that anything that's a multiple of 10 must be divisible by 2. But once again, guys, I actually say that I knew this without doing all this work. Why? Because I know what 10 is composed of. If you know what a number is composed of, you'll automatically know what he's divisible by. 10 is the same as 2 times 5. 10 is composed of a 2 multiplying by a 5. Therefore, the 10 times tables are the meeting point of the 2 and 5 times tables. It's the overlap of the 2 and 5 times tables, meaning that the numbers that are shared by both the 2's and the 5's are on the 10 times tables. Let me show you what I mean. Okay, let's think about our 2 times tables. Our 2 times tables go 2, 4, 6, 8, 10. I wish I had more room, but I'll just go for a little while to prove my point. I think I'll try to get up to 30 if I can squeeze it in. 30, I kind of got it. There we go. Okay, so 2, 4, 6, 8, 10, all the way up to 30, and I'll think about my 5 times tables, 5, 10, 15, 20, 25, 30, and so on and so forth. Okay, now there's some overlap on these times tables. There's some common multiples, some numbers that they share in common, and you can see what they are, 10. And then they have 20 in common. They have 30 in common. Look at that. That looks a lot like the 10 times tables, doesn't it? Since 10 is composed of 2 and 5, the 10 times tables are the common factors between the 2's and the 5's. Okay, wonderful. So correct answer here. If a number is a multiple of 10, it must be divisible by which of the following? It must be divisible by A, that's 2, and C, that's 5. Great. If you have any questions about this or any other GED math topic, be sure to drop it in the comments, and I'll do my best to answer it.